Hello, everybody. Let me introduce again. My name is Miloslav. I'm a senior. I represent the work which was prepared by Miloslav Junior, my son, and my nephew, Jiří, which performed master thesis in this topic. At first, I would like to introduce our research center. Regional Technological Institute is a part of Faculty of Mechanical Engineering at University of West Bohemia. Now we have approximately 80 researchers in our research center and 8 departments. 4 of them are testing labs. One of 4 testing labs is dealing with the strength and fatigue life testing. Our lab is equipped by electrohydraulic equipment of Czech producer Genova. We have 6 independent electrohydraulic cylinders, channels, and some machines for uniaxial and multiaxial testing. For fatigue life calculations, we use ENCODE software. We have a lot of collaboration with Czech producers of various equipments, machines, and transport means in the testing of further nodes and further components. You can see some example from our activity on this picture. Motivation for doing the experimental investigation of Welds with application of HFMI technology is my friendship with Professor Kumenhofer from Karlsruhe Institute of Technology and Zuher Barson from KTH Stockholm. Zuher is co-author of AAW recommendation for HFMI treatment for improving fatigue strength of the joints. And they both persons inspired me to apply to the Czech Technological Agency 2 projects. One is the producer of rail vehicles, Škoda Transportation, and the second is my friends from Czech Technical University in Prague, Department of Steel Structures. Both projects will finish this year. Now I would like to mention something about HFMI, very easy. There are a lot of equipments for application. This technology, we use the equipment of a company, HiFit. Our industrial partner, Škoda Transportation, use the equipment of a company, Pitec. Both companies are from Germany. Principle of the technology is the application of a high frequency impact with different indenters, different sizes of configurations, and the results of application of HFMI is improving the microgeometry around the weld tube. It means the lower notch in this area, and mainly introduction of compressive stresses in the area of the weld. IIW recommendation said that by application of HFMI, you can use the higher fat class for classification of the weld. If the weld is this application of HFMI technology, and if you have a strength with a high and higher, both higher strength, you can use higher and higher value of the fat class. Reason is probably that in steel with higher yield strengths, you can introduce a higher compressive stress by this technology. Now I will speak about the 4 activities in this area. In cooperation with the Škoda Transportation, we prepared very huge testing program, which is already ending. At the end of the program, we will have 90 SM cars for 3 basic materials chosen by Škoda Transportation, 7 weld configurations that are used at the construction of vehicles of this producer in condition as welded, and this without and with HFMI. We studied 3 thicknesses of steel plates. It means we have very huge testing matrix. You can see back of the test specimens from our lab, and sorry. Yeah. This is the only examples of experimental results. You can see, for example, on these 2 pictures that the strands for the you can say standard structural steel will better from 170 to 195, and we use strength with higher yield strength. Improvement is higher. Our experimental results, you can say, are in agreement with the recommendation, but sometimes we have another experimental results. I think it's a normal situation, and because we are in contact with the Zuerpa, so we can communicate our results with them, and maybe our results will be introduced little to the second edition of the recommendation. We performed an internal project because interesting thing is additional bending for the welds. We are happy to use this type of stand to investigate this joint with filled welds, and again you can see only examples of the result. This application of HFMI for this type of steel, and this you can see again that improvement of the fatigue strength is better when we apply this technology to the steel with higher yield strength. Okay. In cooperation with Czech Technical University in Prague, we investigated plates of a large sheet thickness, because in collaboration with Škoda Transportation, we investigated the thicknesses 6, I think 12 and maybe 15 millimeters. And with Prague, we investigated experimentally samples of thickness 90 millimeters and 80 millimeters. The specimens were produced of this structural steel. You can see some information about the welding. I'm not an expert in welding, I will not comment it. That part of the investigation was the testing so-called new samples of thickness 90 millimeters. We prepared for bending. You can see that the stress range was 130, calculated and measured. You can see asymmetry of cycle, and you can see results of a number of cycles for as welded version and version of this application of HFMI. You can see that the fatigue life is higher, 3 to 4 times more. Then we obtain samples with the name old of a thickness 80 millimeters. They were tested before we obtained the test specimens at a stress range which was lower than in former example, to the approximately 1 million cycles. And we found by non-destructive testing macro cracks on 6 specimens on 10, and it was an opportunity to deal with repair welds on this type of welds of plates is high thickness. You can see some pictures from process. Crack was ground down, then welded, and HFMI was applied. And you can see again the results. There's HFMI, no cracks, there are 10 million cycles. It means the technology works well at this type of weld. We can perform the intermediate summary that it's possible to repair the weld and increase its service life. We can calculate that durability increased by factor 3 and fatigue strength increased by 50% when slope as 3 is assumed. Now to the master thesis. We use again our test stand. We use the T-joint with fillet welds. As a parent material was used the structural steel C4060. Again, are some information about the welding process. We loaded the test specimen with a constant load range controlled by applied force. This is stress ratio near 0.17 with 10 Hertz. It's very easy to measure by strain gauges or calculate the stress ratio for this type of loading. And before the official program, we tested the criterion for appearing the macro cracks, and we used as a criterion the loss of stiffness of these specimens. It means that the deformation of loaded part was approximately 3 millimeters. At this time, we obtained the knowledge that the macro cracks will appear at the weld too. Okay. This is a statistic of all tests. You can see that some specimens run out 10 million cycles. It means from the 12, only 9 was possible to use for repairing the weld. We used 5 weldments for application of HFMI after the repair, or was used without the application of HFMI, and you can see the results. If sorry. Yeah, maybe if we have these ambitions to create the second curve of this 2 level only, you can see that repair welds sometimes can be better than initial welds, but main information for us is that the repair welds with HFMI technology are very good. I still think that we can perform the conclusions from the qualitative point of view. We can say that our work has confirmed that the HFMI is a very effective method for improving the repair welds, and it means can be used on existing structures, for example, steel bridges. For qualitative description, we need a much larger experimental program, I think, to agree or disagree that the HFIW recommendation can be used without any changes to the repair welds as the initial welds. For example, this is a topic for further research because we would like to continue in this type of research because we have 90 very good SNCF which were created from 12 to 20 test specimens. We hope that we will be able to perform the training, the data. Also, SNCF created for materials, different thickness plates, etc. And we would like to try to predict the additional SNCF for other materials and other thicknesses, etc. And predicted values will be tested experimentally again to say that our neural network is working well. I think that the application of HFMI technology can be tested on other steels and aluminum alloy too. For this is necessary to collaborate with the producer of equipment. Then, by recommendation of a working group 13 of IIW, we would like to apply the block loading of this type of welds, and mainly we would like to move for testing the rear structures and components. Thank you for your time and your attention.